Pressing on the brake pedal slows a car down from a velocity of 35 meters per second to 20 meters per second in 8 seconds. Assuming that the acceleration is uniform, what is the displacement of the car? So, what we'll do is use this formula, which is S equals U plus V, which again, this is initial velocity and final velocity, and S is distance, divided by 2, in parentheses, times time. So we just have to solve this formula, and that would just give us the answer. Let's see. U plus V would be 35 plus 20, which this is just equal to 55. So equal 55. Then they tell us that we have to divide this by 2. So 55 divided by 2 would equal 27.5. And then 27.5, they tell us we have to multiply it times time. So we have to multiply it times 8. So 27.5 times 8. And I would just put into the computer. 8. And we solve 220. So 220. That would be our displacement in meters. So let's change this to our marker. Meters. And that would be it for this one. A sports car starts from rest and has a uniform acceleration of 1.2 meters per second squared. What is its velocity after 30 seconds? So here we use our formula: final velocity equals initial velocity plus acceleration times time. Since initial velocity is 0 because this starts from rest, we can eliminate that. And its final velocity equals acceleration times time. Oops. Acceleration times time. And so we just solve this by saying by putting acceleration, which is 1.2 times 30, which would equal us 36 meters per second. So now we have the A part solved, but they ask us how far does it go. So this is the same as the first one. It's just the same formula. S equals U plus V divided by 2, parentheses, times time. So now, the thing we should do is, since this starts from rest, we can eliminate U. So V, we said it's 36, divided by 2, 36 divided by 2 equals 18. And they say 18 times 30 seconds. So 18 times 30. Oops. 30. This. Well, I would put in the computer. This one. So I have a bit more space. 18 times 30 equals 540. So, in that time we're breaking, which is 30 seconds, we would move 540 meters. There you go. You have a answer here, 36 meters per second, and 540 just meters. Next, an object is dropped from a balloon descending at 4 meters per second. Lands on the ground 10 seconds later. What is the altitude of the balloon at the moment the object was dropped? Well, first let's see what data do we have. We have initial velocity, u, which they said is 4 meters per second. Then we ask us for distance. Well, let's put it here. 4. Distance is our incognita. Then we have final velocity, which we don't know. We have acceleration, which is 9.81, but let's just put 10 for simplicity. 10. And time, which they say it is 10. So here we could use our formula, which is S equals UT plus 1/2 0.5 AT squared. So AT squared. Since we have to solve for S, it's already in the right place. And so this we'll just have to solve it. S equals U is 4 times 10 is 40. Plus 1/2 10, which is acceleration is 5. 5 times 10 squared is just 100. So these two would give us 500. 40 plus 500. 40. And then 40 plus 500 is 540. Oops. 140. So then this would be meters, because they ask us for distance. So that would be our answer. A car traveling along a highway must uniformly reduce its velocity to 50 meters per second in 30.5 seconds. If the displacement traveled during that time interval is 70 meters, what is the car's average acceleration? So it says acceleration uniformly reduced to 15 meters. So that would be, well, let's find the things we have to get our formula. So first they say it reduces its velocity to 15 meters. So that would be V, which equals 15. Then we have T, they just tell us it's 3.5. T, 3.5. What's the displacement of the car during the time interval? No, if the displacement during the car interval is 70, so this is S equals 70. What is the car's average acceleration? What is its initial velocity? So first they ask us for acceleration. So A. Well, we're trying to solve for A. Oops. So yeah, so the formula I would use is really similar to the one here, but it's just a little bit different. Instead, it also starts with an S equals VT minus 1/2 AT squared. So it's really similar because the second part here are the same, and basically you can just change the U, this U here, for a V, if you put a minus. So now we would solve it, saying that S is 70 equals VT, which is 15 times 3.5, which would be 52.5. And 52.5, we would have to put a minus times 0.5. 0.5 acceleration and 3.5 squared. Well, that one we have just ask the computer. 12.25. So that's times 12.25. 12.25. So then, what we would do is we would multiply the 0.5 times 12.25. So let's go on Peter 2. Times 0.5 equals 6.125. So that's well, that's what the three parts give us. And then, so we would have right now 70 equals 52.5 minus 6.125. Let's see if we can fit that. 125. Wait, let me just get this. Slow words. This. Put that there. So it's minus 6.125, and this times acceleration. So now the way we would do it is we would have to go simplifying this. So acceleration is the only thing left here. So we would pass the 52.5 to the other side, negative. Negative. So that would give us, well, that would be 70 minus 52.5, which that would equal 17.5. And so 17.5 would be, we would have to pass the 6.125 dividing five. Now I'm going to ask that to the computer. 17.5 by 6.125. Oops. 2.8571. So then that would be our acceleration of 2.86 basically meters per second squared. So yeah, but since up here the 625 was negative, when we pass it, it'll still be negative here. So when we do the division, we'll get negative 202.86 meters per second squared. So now they ask us, what is its initial velocity? So this one's really easy. We just gotta multiply acceleration times time. For now, let's just do 2.86 times time, which is 3.5, times 3.5 equals 10.1. And 10.1, we have to add to 15, because that way, since it's reducing its velocity, we know that it will be bigger, so we gotta add it 10.01, giving us 25.01 meters, and 25.01 meters per second. And that's it for today. Thanks for watching. Don't forget to subscribe and hit that bell.